Welcome to the session of op-amp and linear circuits laboratory. In this session, we will be discussing the simulation of the R2R ladder DAC. So R2R ladder DAC is nothing but a digital to analog converter. Using a op-amp, we will be drawing the circuit of this R2R ladder DAC for a 4-bit input and observing simulating this DAC using the NI multisim software. So in this case now, so moving on to the design part, design a 4-bit R2R ladder DAC using the reference voltage of 5 volts. The output voltage V0 is nothing but minus V reference times B3, that is the most significant bit, divided by 2 plus B2 divided by 4 plus B1 divided by 8 plus B0 divided by 16. B0 is the least significant bit. So in this case now we will see the circuit diagram. So this will be the circuit diagram where B3 is the MSB bit and B0 is the LSB bit. We are using the values of R and 2R. As R we are using it as 1 kilo ohm, so 2R will be 2 kilo ohms and reference voltage will be equal to 5 volt, what we are going to consider. And this is the circuit diagram what we will be executing in our NI multisim software. So directly we will move on to NI multisim software to observe the waveforms here, and then we have to verify this particular table, that is the truth table what we call for different values of digital inputs. Moving on to this particular part here, so this is the circuit what is already drawn here. So in this case now this part is the MSB bit and this will be the LSB bit. So we will just remove these connections at for a while, and for 0 0 0 the output will be equal to 0. So this is a meter what we are going to use, and this multimeter will give the value of voltage since we have connected it volts, and this is the DC part what we are considered. So we will first go for the all bits equal to 1. So I will connect this all input bits, that is B3, B1 and B3, B2, B1 and B0 all are connected to I state values, that is nothing but it is connected to 5 volts, and we will execute this particular. So when we execute this particular part, we get the output voltage as minus 4.685 volts. For all the bits equal to 1, the output voltage will be equal to minus 4.685 volts, since we have connected V1 to 5 volt supply. So I will stop execution of this, and moving on to this particular part, so we get minus 4 point. So we will execute for 1000, that is the decimal value of 8. We should get minus 2.5 volt. So in this case this is 1, rest all are equal to 0. So this I will disconnect this particular part of the output and directly connect this to ground at this particular part. So this is connected at this, and this is also connected to this part here. So B3 is connected to 1 and all other values are equal to 0. So in this case when we execute this, we get minus 2.498 volts, and this will be the output voltage for 1000. And next, moving on to one more case we will just solve here. So for 1100, so if we consider that particular case, so this has to be connected to 1, so 1100. So if we execute this, it will be minus 3.748. So by this case, so by changing the digital inputs, that is digital inputs are nothing but we are connecting it either to the 5 volt supply or to 0 volt supply, and then observing the output. So we call it as a digital to analog conversion. In this case we get 16 different various values of the output. So this will be the experiment of a R2R ladder DAC, which is a 4-bit DAC what we can call. Depending upon the number of bits we can obtain the output voltage. So thank you for watching this particular session.